Audio Jungle. Audio Jungle.
Sir, am I audible?
So for the 1D, you had calculated strain because it was a longitudinal direction or in L direction. So you had said this is epsilon L, or because it is also X direction, so you can say epsilon X. So it is nothing but delta L by L, and that was the value. It was strain is nothing but stress divided by Young modulus, and you know that stress is the area for this is nothing but A, then stress will be P by A divided by epsilon, and ultimately you got P by A. And if I say what is the change in length, then you said it was PL by A. So because you are considering 1D system, this is the one-dimensional system. Okay, first case. Till now you had seen. Even though for this diagram also it will be the same thing, because it is 1D, but it is in y direction. So if you calculate here also, so that delta L change if you see, then it will be PL by A. For this also it will be same. If I say 2D or two-dimensional stress system, okay, so what will happen? This is the 1D system, one-dimensional stress system. If you talk about the two-dimensional, then what will, so here that strain is nothing but, you say strain is nothing but B by A, or you can say simple sigma by E. Okay, sigma by E, that means stress by Young modulus. That is the strain. This is for 1D. This is for 1D system. 1D stress system. Now we'll talk about the 2D stress system. So what will be the condition for the 2D stress system? So we can write here 2D stress system means two-dimensional stress system. So in two-dimensional means you have taken the bar like this, and here you can say this is xy. You can take this is what x and this is what y. So this load is nothing but px this side, and in this direction it is py. So this is called 2D stress system. So obviously this is what py. So stress here will be sigma y, and this is the px. So stress here it will be sigma x. So because now it's a 2D stress system, so definitely that strain will also be in x as well as y direction. But it doesn't mean like a strain you are writing in x direction, then that effect will come in y direction also, and that it was defined Poisson ratio. Okay, if you remember the Poisson ratio, so Poisson ratio was Poisson ratio was lateral strain divided by longitudinal strain. So if I say lateral strain, then it will be mu into longitudinal strain. Now just think about this diagram. Suppose for this diagram, if I say the load, tensile load is what acting in this direction, which is nothing but x direction because of this tensile load px. So in x direction, that elongation will be positive, but at the same time in y direction that width will be decreasing. Why? Because elongation we have. So in this y direction, that deformation will be negative. And how you would understood this? That was the relation between the Poisson ratio and lateral and longitudinal strain. So this y direction strain, how you will measure? With the help of this formula, that Poisson ratio is equal to lateral strain into longitudinal strain. So now if you are talking about x axis, so in y direction it will be lateral strain. Similarly, if you are saying, if you write for this x direction, so whatever the strain you will get in x direction, that will be positive. So what is the strain in x direction? It is the epsilon s, and it will be sigma x divided by E, and this will be positive. Why? Because it's a tensile load in x direction, that length will be elongated here. Okay, number one. Number two, but you talk about the y direction also, because now for this bar, if you are saying it's a 2D system, so definitely because of this load in x direction, that will also affect in y direction. I mean the deformation, or maybe it is elongation, or maybe it is contraction. It depends on the nature of the load. If it is tensile nature, then elongation in x direction, and in y direction contraction. And if it is the compressive nature, then in x direction it will be shortened length, and in y direction it will be elongated. Okay. So if you talk about epsilon y, so in epsilon y, that will be lateral strain, and lateral strain is nothing but Poisson ratio into longitudinal strain. Poisson ratio into longitudinal strain, and so this is the Poisson ratio into longitudinal strain. In y direction, it will be sigma y by E. But what will be the value here? It will be negative. Why? Because it's the tensile load. So in y direction it will be elongated. So this will be because of the x. And similarly, if you talk about the load py, which is in y direction, then what will happen? This is the epsilon x I'm saying. I mean, we just combine this. Okay. So once you combine, then again I will write this. So now what will be the strain in x direction? That will be the strain in x direction, which will be the positive because there is the elongation. But at the same direction in y direction, that will be the lateral strain, and it will be Poisson ratio into longitudinal strain in y direction. And it will be negative. Why? Because if in x direction it is elongated, then in y direction it will be shortened. So minus Poisson ratio and strain in y direction, that is sigma y divided by E. So this is what epsilon is. Similarly, you write epsilon y, that is strain, because it's a 2D system, so obviously 2 strain will come. So now if you are talking about epsilon y, so that means first you will take in y direction. So it's in y direction, what is the load? It is py. So what will be the stretch? It will be sigma y divided by E. But because of the y load in y direction it will be positive strain, but in x direction it will be negative. Why? Because once this in y direction, if this bar is what elongated, then in x direction it will be shortened. You just think about it. Then it will be minus mu sigma x by E. So this is the method to write the strain for the 2D stress system. This is the method for the strain in 2D stress system. Alright, always remember this. This one is clear or not? Okay, so this is the 2D stress system. Now we'll go for the 3D stress system. Stress system. So how to draw this as a diagram? Basically for the 3D stress systems, you can say okay, this is the 3D stress system. So now if you check, wait, fine. Now if you draw the 3D stress system, so now it is fine. This is the accurate diagram. So if you draw the axis system here, so this is what y, this is what x, and this is what z. Now if you apply the load in x direction, in y direction, so this is the x direction. So on this phase, suppose the load is what, px. Okay. Similarly, this is the y axis, and on this phase the load is what, acting, py. And the another phase, suppose this is the another phase. So here I must draw the color here. This is the z phase, and here the load is acting z. So definitely stress will be sigma z, sigma x, and sigma y. Just like here I have drawn pz. Similarly, you can draw the y phase where the load py is acting. That phase I have, and this is the phase for the x-axis. Now hope this one is clear. Alright, now so definitely it will write the strain for in all direction. So in x direction, so same concept you have to apply, epsilon x. If you are writing strain in x direction, so first if you are writing in x direction, so sigma x by Young modulus, that will be strain in x direction, and this will be positive, sigma x by E. But what about y and z direction? Now it will be treated as a lateral strain. So what is the lateral strain? It's a Poisson ratio. And what about the deformation? It will be positive or negative? Definitely it will be negative, because you are considering load x, load in x direction. So other side, that deformation will be negative. It will be shortened. Why? Because in x direction it is going to elongate. Once one side it is going to, let's take this example so you will understand. Suppose this is the bar. Now if you x direction, if you have load px, okay, if you apply load this px, so what will happen? So here elongation you may get like this because of the px. But what about this diameter? This diameter will be shortened. I mean this diameter will be decreasing. Why? Because in x direction we are getting elongation. So this elongation will be delta L, which is positive. But in this case, because this is what, suppose capital D, now this is the small d, so here In this case, I will draw the dotted line here, so it will be better. So this length is what decreased here. This length is what decreased. Why? Because in x direction it is elongated. Hope you understood. So the same way in x direction, because of px load, will be positive elongation, but in y and z it will be negative, and it will be treated as a lateral strain. So lateral strain will be Poisson ratio, because it is in y and z it will be shortened, and in x direction it is positive, so make positive sign if you want here, but in y and z direction you make negative, and lateral strain will be Poisson ratio into strain in y and z directions. You are writing y, so this is sigma y divided by E minus mu sigma z by E. This is the strain in x direction. Similarly, you can write the strain in y direction. So it will be epsilon y. What will be the epsilon y? So epsilon y, now you are talking about, if you are saying y direction, so you are talking about the load py. So because of py in y direction it will be positive deformation, hence it is sigma y by epsilon, sigma y by egg modulus. And rest x and z direction it will be lateral strain, and it will be shorten the length, hence it is sigma mu Poisson ratio into, in x direction it will be sigma x by E minus, or it's your choice, if you are going for the cycle, if you are following this cycle, this is what x, this is what y, and this is what z. If you are thinking you are writing x y z, then next y and it will be z. It's your choice. If you are following the cycle, then you write z, but rest two values will be negative. That is my point. So this is sigma z by E minus mu sigma x by E. Similarly, in z direction, if you say in z direction, what will be the epsilon? It will be sigma z positive, but in x and y it will be negative. So it is sigma x minus. So this will be the strain in x, y, and z direction. I hope this one is clear. For strain for 3D, stress system, you had seen epsilon x, which is nothing but 1 upon E in bracket sigma x minus sigma y plus z. Epsilon y, it is 1 upon E in bracket sigma y minus mu sigma x plus sigma z. 1 upon epsilon, it is sigma z minus sigma x plus sigma y. So this is all about strain. Now the same thing, if you go for the stress, you have to write this equation, you have to check the manipulation. Okay, a little bit calculation you have to perform. I mean 4-5 steps you may have, simple mathematics. If you do that, then finally you will get the result, and that will be for the stress. So if sigma x, sigma y, and sigma z they have given in all three directions x, y, z, then what will be the epsilon x, epsilon y, epsilon z? This will be the formula. But suppose they have given in all three directions in x, y, z. Suppose they have given a strain. So for the strain, how to write the result for the stress? That is the main motive for the result here. So that time you will write the stress in terms of strain. It will be sigma x is equal to E upon, that is the Young modulus, E upon 1 minus mu square E upon 1 minus mu square in bracket epsilon x plus mu epsilon y epsilon z. It is E upon 1 minus mu square. It is epsilon y. Okay, in the same way you can write epsilon y plus mu epsilon x plus epsilon z. Sigma, similarly sigma z. Okay, you need to remember this result I am giving directly. If you perform the calculation, then you will get it. Clear?
Yes, sir, clear.
It's a simple one. You perform mathematical expression, you write that, then you will get it. So, as I have mentioned in starting only, that derivation is not important at all. The important point is here, at least in computation, you should know the final result or final formula, then you will able to solve the problems. Okay, that is the one thing. Second thing, after having this 3D stress strain system, we will now move to principal stress and strain. Okay, principal stress and strain. What is the mean of it, and like that orientation of the principal stress? What is the principal stress? That is the one question first. What is the principal stress? So all those things we have to discuss. So this is the new chapter called principal stress and strain.